Welcome to The Explainer. Today, we are diving into the physics that makes everything go. We're talking about work, energy, and power. These are the basic rules of the game for, well, everything, from hitting a baseball to riding the world's craziest roller coaster. All right, let's kick things off with a question you've probably wondered about. Picture a roller coaster. You know how it gets dragged up that first massive hill, clink, 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 clink? And then for the rest of the ride, there's no engine at all? How in the world does that work? So, to solve this roller coaster riddle, we need to get our heads around a word we use all the time, work. But here's the thing. In physics, work means something very, very specific. And it's probably not what you think.
I mean, think about it. You might say you did a ton of work studying for a test, right? Or your arms are burning from working to hold a heavy shopping bag. And hey, in day-to-day life, you'd be totally right. But when a physicist hears that, nope, it's a whole different ballgame.
This is where it gets kind of wild. You could be completely wiped out after a long day of studying, or your muscles could be screaming from holding a super heavy weight without moving an inch. And according to physics, you've done absolutely zero work. Nothing. Nada. Because for a physicist, the only question that matters is, did anything move?
Okay, so here are the two golden rules for work in the physics world. It's really simple. Number one, you have to apply a force. You got to push or pull on something. And number two, that something has to actually move. It has to cover some distance. If one of those is missing, especially the movement part, no work has been done. End of story.
And this all boils down to a super simple but really powerful little formula. Work is just force times distance. That's it. It's why you can push on a brick wall with all your might until you're blue in the face and still have done zero work. You're applying a force, for sure, but the wall's distance moved is zero. So force times zero is zero. All right, so if work is the thing that gets done, what do you need to actually do it? Well, that's where energy comes in. You can think of energy as the currency for doing work. It's like the cash you have to spend to make anything happen in the universe. And honestly, the best way to wrap your head around this is to imagine an energy bank account. You can put energy in, that's a deposit, and you can take energy out to get things moving, that's a withdrawal. So let's go back to our roller coaster and see how it manages its account.
Okay, that first big deposit, that's the chain lift, right? Clanking that roller coaster car all the way to the top of the first hill. The work it's doing against gravity is like loading up the bank account. This stored energy is called potential energy. It's just sitting there, a huge pile of cash in the bank, ready and waiting to be spent. And then, that moment of truth. The car teeters over the top and starts to plummet. What's it doing? It's making a massive withdrawal. It's cashing in all that stored up potential energy and turning it into the energy of pure motion. We call that kinetic energy.
So think about it. At the very, very top of that hill, just for a split second, the car's barely moving. Its bank account is full to the brim. That's maximum potential energy. But it has next to no kinetic energy because it's not really going anywhere yet.
Then, bam! As it hits the bottom of that first drop, the situation is completely flipped. The potential energy account is basically empty. Why? Because it's all been cashed in and converted into raw, blistering speed. That's maximum kinetic energy. It's moving as fast as it's going to get.
And this back and forth, this constant trade between potential and kinetic energy, that's the secret to the whole ride. It's this beautiful dance happening over and over again. And it's all governed by one of the most basic, unbreakable laws of the entire universe.
You've probably heard of it. It's the law of conservation of energy. And it just says this: you can't create energy out of thin air, and you can't destroy it. The total amount of energy you start with is the total amount you end with. It just changes its shape.
But hold on a second. If that's true, that presents a bit of a problem, doesn't it? If no energy is ever lost, shouldn't that roller coaster be able to climb a second hill that's just as tall as the first one? So why is it that on every roller coaster, the next hill is always smaller? Well, the answer is that our perfect little energy bank account has some hidden fees, a service charge, if you will. The energy isn't destroyed, but some of it leaks out of the system. Think about the wheels on the track. That's friction, and it creates heat. And the air pushing against the car, that's air resistance. That lost energy turns into heat and sound. You can hear the roar, right? And you just can't use heat and sound energy to climb the next hill. Okay, so let's recap. We've got work, which is force times distance. We've got energy, which is what you need to do the work. There's just one more piece of the puzzle we need to put in place, and that is power.
So, what's power? It's all about how fast you do the work. It's not about how much work you get done, but the rate at which you do it. Think of it this way. If you do the same amount of work, but in half the time, you've used twice the power. This is a great example. You've got two people, both climbing the same rope to the same height. So they've done the exact same amount of work, right? But one of them scrambles up there in 20 seconds, while the other takes 50 seconds. The faster one is way more powerful. It proves it's not just what you do, but how fast you do it that defines power.
And that brings us to one last kind of mind-blowing thought. That same law of energy conservation, it applies to you right now. The energy from the food you ate is being converted into tiny electrical signals in your brain, allowing you to have thoughts. And that energy doesn't just disappear. It actually radiates away from your body as a tiny, tiny bit of heat. So where does the energy that powers your thoughts actually go? Well, it goes out into the universe. Every single idea you have makes the cosmos just a little bit warmer.